Good morning. Myself Rajkumar, working as an assistant professor in St. Joseph College of Engineering. So today we are going to discuss about the B plus tree, which have in the database management system. Okay. So what is the topic is B plus tree. Okay. So where we are using this B plus tree means we are using in the data structures. Okay. Then now why we put in the data structure, that is a DBMS means. So we are going to have the storing retrieving process. We have to structure your data. So for the structuring purpose, we are go for the B plus tree. So what is a B plus tree concept? It is called as a self balancing. Okay. So you're going to balance your records. Okay. So for inserting, searching, deletion, that can be, we can possibly means if we have the data into we have a structured format. For the structure format, we are going with the B plus tree concept. Okay. So what are the key features in the B plus tree means? We have the 5 key features. Okay. So first thing, all nodes we have in the leaf node. Okay, that is called as all nodes. All nodes in your leaf. Okay. So whether we have any root node or child node, in this basic concept, we have the all nodes near the okay leaf node. So then one more thing is, if we have a key, the key should be have in your root node. Okay. So we have an order means that order should be have maintained for your insertion purpose and deletion purpose. Okay. So that should be we have to keep. The key features means we have that all nodes should be in your leaf node. Then the each node should be have the self balance. The final structure should be have that leaf node will be have the self balance. So all leaf node will have the same. Okay. Then what is the order means we have the time complexity of this order of log n. That is your concept of your time complexity. Okay. So these are the key features. Okay. Then what is the need of this means? I told already. We are going to insert a new item in your going to have that record, or you are going to insert pushing your item frequently. So if you are going to storing your data in a structure format means, if it is easy to access when you are going to retrieve the data, or when you are going to add new data with existing data, or you are going to deleting the data from the existing data. So this will be make much easier when you are using your B plus tree concept. Okay. So one more advantage is we have that leaf node will be have the linked with it. Okay. So all leaf nodes are we have the linked. Okay. So it start from your in beginning to end. This all leaf node will have a link. Okay. So that is a main need of your B plus tree. Okay. So this is the concept of your B plus tree. So why we are using in your database. Okay. So we have that database is going to have the dealing with the only managing your data, that is storing, retrieving, searching, inserting. This purpose only we are going to commonly using. So while using your B plus tree means this will be more simpler and much easier to you are going to processing these operations, search, insert, delete. Okay, this kind of operation will be have that much easier when you going for the B plus tree. Okay, so now we are going to give an example. With an example, we are going to see this. What is a B plus tree? Okay, we have the concept of internal node. Okay, so let's take the structure of a B plus tree. So this entire thing will be comes under your internal node. Then this will be comes under your leaf node. Okay. So what is the internal node means? The internal node will be having a responsibility of your key nodes. Okay. This leaf node will mean have that all other remaining things will be having your leaf node. Okay. So the key nodes will be take care of your internal node. The internal node means it's a key nodes. Then what is the leaf node mean? We have the remaining part should be comes under your leaf node. Okay. So let me have taken an example of your B plus tree. So construct your B plus tree using your, what is the items we have done, okay? 10, 20, then 5, 6, 12, 30, 7, 17, okay? So this is your notes. You are going to get done the operations with your B plus tree, okay? So what are the operations means? We are going to done with the insertion first, okay? So the insertion means we are going to follow by the step by step. So what is the order here, okay? So we taken as an order of 4, okay? So what is the order means? We are going to have that inserting and deleting means we have the keynotes of your thing, okay? So first thing is, what is that? Maximum, okay? So max of notes, that can be means m minus 1, that we are going to, what is the m? That is at order 4. So total 3 notes maximum we can hold in your keynotes, okay? Then next, what is the minimum? So minimum means we have this m by 2, okay, minus 1. What is the 4 minus 2 is 1, 1 minus 1. So minimum 1 note we can able to keep, okay? So for that, this is the process of you are going to inserting your notes, okay? So first basic we are going to take as an insertion of 10. That is a step 1. Insert 10. That order we have that, what is it? 3, okay? Then we have this empty. This is your step 1, okay? So what is the step 2? We have that inserting your another key, 10, 20, okay? So what is the step 3? We are going to insert next key. Step 1 inserting of 10, then step 2 insert of 20, then step 3 insert of 5, okay? So now we are going to insert 5. Where we have to insert? That should be have your beginning of your note, okay? So 5, 10, 20. So what is the concept here? We have the maximum, how much we can note? We can hold your the maximum of 3 notes in your key concept, okay? So what is the thing? Next we are going to accept of your step 4, okay? So next item means we are going to insert, what is the next note? This is 6. So where we are going to insert? We are going to insert in the middle of this, okay? This is before, after 5 and before 10. So while we are inserting, what will happen? So it is your have the overflow, okay? So what is the overflow? We can't hold your the 4 notes. What is the concept here? What is the note? So maximum note we can hold only 3, okay? So that is your order 4, okay? So we can't able to insert your 6 in the end. So what we can do, we are going to split it, okay? So what is the split purpose we are going to use here? We are going to split your the notes what we have already, okay? So now I am going to split that. Okay, so now we are going to, after the split, we have the root node of 10, we have that another node of 5 and 6 will have the leaf node, then 10 and 20 will be the leaf node. Okay, so the B plus tree concept, what we have in the root node, that should be present in your the leaf node too. Okay, so that is a concept of your B plus tree. Okay, then next we go for the step 5. What is the step 5 means? We are going to insert the upcoming another node. Okay, so insert 12 in your entering node. Okay, so where we can insert your 12? Here. So we can insert here. Okay, because we have that highest value is 20, the lowest value is 5. So in between we have to insert your new node. So where we can possible means, so in between 10 and 20 will be the possible. So we have already free node also here. Okay, so free space is there, so we can insert. Okay, so we insert here, this is your new node. Okay, so after your this step, what we have done, we have insert by each step by one node, by each node by one. Okay, so now we go for the step 6. We're going to insert 30. Okay, so we have insert that 3, 4, 6, 7, 8. 8th node in your node. Okay, so while we are inserting this 30, what we have keep it. So we can is a possible. Where is a possible? At the end of the 20. Okay, that is a possible thing we can able to keep here. Okay, so what we can do, we can add here means that is that already it's an under condition. Okay, I'll show that is that overflow condition will occurs. If we can insert, is an overflow. Okay, so what we are going to, again we have done the split. Okay, so what we are going to split here, we are going to split that existing from this node. Okay, so this leaf node we are going to split that. Okay, so what is the possible split? Any idea? So already we have the root node is 10. Okay, so we can able to move that another key from node to another node, that will be have a possible of, we can get the one more free. Okay, so what we are going to do, I'm going to push that 20 to the key node, 10, 20. Okay, so now we have that 5, 6 will be have already is there, then 10, 12 will be holding here. The next thing is we are holding 20 plus 30. Okay, so after this we can going to push that one leaf node to your other root node, then we can have the free space here. So we are going to insert that new concept of, we are going to splitting that root node of 10 and 12 we have the another node. Okay, leaf node, then we are going to create a new leaf node of 20 and 30. Okay, so already we have that each node having the two values, so there's two pairs of node here. Okay, so 10 and 20, 5 and 6, 10 and 12, 20 and 30. Okay, so total we have this. Then next we go for your step 7. Okay, so this step 7, what is the value here you can start? We are going to insert this 7. Okay, insert 7. Okay, So already we have a, where is this free space here? So we have a free space here. Okay, so there is no any possible things of no here. Okay, so we're going to directly insert value here. And 12 here, then remaining 20, 30. Okay, so new node will be have inserted here. Okay, so that is your the step 7. Okay, so here we don't have any split process because we have already split space here. So we are going to insert here the existing node, that is we are going to have inserting new node in the existing leaf. Okay, so the next we are going to have that. Okay, so this is step 8. We are going to insert new key, that is a 17. Okay, so where we can able to insert here? So already we have a free space here. Okay, so it is a possible thing we can able to insert here. Okay, so what I'm going to insert your the b plus 3 will be have here 10, 20, 6, 7, then here we have that 10, 12, then 17, later here we have that 20, 30. Okay, so we have insert the final step, we insert the all nodes. Okay, then we make as a link between the leaf node. Okay, that is the main thing. Okay, so we must satisfy these rules of that. What is that? We are going to maximum node we can hold that only 3, and minimum should be have that each node having at least one node. That is it, each node have only one key at least. Okay, so what is the node here? We have that internal node already. I told that which holding only key values. Then leaf node will holding that all other remaining values. That is your leaf nodes. Okay, so what is the key node here? The key node will be have the 10 and 20. You will be have your key nodes. Okay, then this one will be having your leaf node. Okay, so now we made to understand your what is the b plus c operations will what we have done. Okay, so we are going to insert this keys of this order. Some here the keys 1, 10, 20, 5, 6, 12, 30, 7, 17. Okay, so one by one we are going to inserting your the values in your keynotes. Okay, so what is the keynote? Already we have initially we have only one keynote, that is a 10, because we are going to insert only one value. Then we have another value is inserted, that is a 20. So 20 we have the two keynotes, all we have the 10 and 20. Then later we are going to insert the 5. So the 5 will be have your existing keynote. So what is the conditions here means we have the maximum 3 nodes can able to hold. Okay, the keynote will be have holding. Then next we are going to inserting the new node, so we cannot able to process here, that is called as an overflow. Okay, so this is an overflow conditions. Then overflow means we are going to have the split process. After the split we have that split that existing node will be have the new key node, that is this is a 10 will be have your new key node. Then we are going to have a 2 leaf node here. Okay, the 2 leaf nodes we have a splitting here from the existing node. Okay, so that will be have done. After done we are going to insert your the new keys, that is a new value of 12. So where we can able to insert means we have the already free space in your the right leaf node. Okay, so we are going to insert in the right or left. So each node can be we are using your concept of right or left. Okay, then next have the step skips we have the 30. So 30 means it cannot be possible in your the right side. Okay, so what is the concept here? We have the maximum of 3 nodes can be possible, so we cannot able to insert here. That is a concern, that the overflow condition. Then what we can do? We are going to again split that sorry, existing node we are going to have that 10 and 20. Then after 5, 6 we are creating this one. What we are going to have that we are going to remove this 10 and 12 here. We are creating as a new node. Okay, then we are going to push your 20 to the key node. Okay, so the 20 will be comes to your key node. After we are creating have a space here, so we are going to have the leaf node of 5, 6, 10, 12, 20, 30. Okay, so then the step 7 is be process of your inserting of a new node, that is a 7. The 10 and 20 will have concept here, that is the key nodes. So where is the free space means the free space should be available already in your the left side of leaf node. The left side leaf node have a one free space. So we directly insert the key of 7. Okay, so then there is no need to for split process. Okay, so only the split process will be needed when we go for your overflow conditions. Okay, so here we don't have any overflow conditions. Then again we are going to insert a new key of 17. The 17 also we don't have any overflow conditions. So finally we have inserted here. Then we have the 20, 30. So you have to check your, that is a balanced tree. So all three, that is we have a balance of parents. So minimum one, that is a concept of minimum one key will be there. Okay, maximum of 3. That is the concept here. So here the leaf node, that is the key node having a 2 keys. Okay, so it should be satisfying the condition. Then the leaf node all have the maximum 3, 3, then 2. So what is the conditions here? The condition is maximum of 3 nodes can be have possible. Then minimum of 1 node much should be present here. Okay, so that concept will be satisfied here. So this is your have a complete B plus tree here. Okay, here we have called as a complete B plus tree. So this is here the insertion. Okay, insertion operation we have done here. Okay, so this is your B plus tree insertion with an example. Okay, so now we have a clear. Okay, so previously we discussed about your insertion operation of your B plus tree. Okay, so now we are going to have the search operation in B plus tree. Okay, so already we have a example, that is we have a complete B plus tree, we have the balance tree. Okay, so here we have the, what is the node here? Key nodes will be have the 2 key nodes, and we have the 3 leaf nodes. So these leaf nodes we are going to find the what is the key we need to find. Okay, so we know already we have the root of 10 to 25. That is we are going to find that range between 10 to 25. We are going to find that what are the nodes we have available here. 10 between 10 and 25. Okay, so we will consider as a 10, that is a less than or equal to 10, or less than or, that is a less than or, sorry, greater than or equal to 10, and less than or equal to 25. That is a key value we are going to find that. Okay, so in the finding concept we have a much easier, that is going to insertion also we are going to have done with the step by step concept. So step by step we are going to find your the key. Okay, so first we have taken this complete B plus tree. This complete B plus tree, we have the 3 leaf nodes. The 3 leaf nodes are, we have that interconnected, that is a linked. Okay, so we have the leaf nodes are linked. So step 1 we are going to find that. Okay, so what is the key 10? The key 10 means we are going to first check with the root. Step 1, so we are going to check that 10. Okay, so key 10 is going to first we are going to check with that 10. So that will be have your leaf node, that is you are going to key node we have a 12. So left side of your node, that is a left child we need to check. Okay, so left child we need to check. So in this left child of your key node, what is the child we have that 5, 7, 10. Okay, so we need to check this condition. Okay, so what are the conditions means? We have the conditions. The root node we have that key will be fall between that less than, that is a less than greater than or equal to 10 and less than or equal to 25. So from this we are going to satisfy what are the conditions is satisfying the key nodes here. So we have the 3 keys here, 5, 7, 10. But which one you fall in the conditions, that is we are going to searching operations, which key means 10 will be have fall, then 7 is no 7 and 5 is not under the conditions, that is you're going to have the search key. Okay, so left side will be completed, then we move to the next child. So once search will be completed, the next child we need to move. That is comes under you have the step 2. Okay. So from this we have what do we have the keynotes here? Okay. That is a middle node. What are the keys we have? That we have a 12 upon 17. Okay. So this 12 and 17 we have here. Okay. So from this we have that node we have already in the conditions. So what is the conditions? We have the between falls between 10 to 25. Okay. So that will be we are going to check in here. So we check with the conditions both keys are satisfying this. Okay. So we take this both key. Okay. So we move to your next child or concept of next node. Okay. So in the step 3. Okay. So this is your right child. What are the keys here? We have the 20 and 30. 20, 30. Okay. So again, we need to check with the conditions of what we are going to search. Okay. So we need to search from 10 between 10 to 25. Okay. So what are the keys we have satisfied? Both will be have satisfying this range. Okay. So both range are satisfied. So we are going to take this 2 that is not between the 30. 30 will not condition. Okay. So finally we found this. Okay. Then this is the end of your child. Okay. Okay. So now we taken the keys where we have selected. That is, we are going to have the 10, 12, 17, and 20. Okay. So what is the answer? Is there's the answer. So final answer is we have taken the range between the keys. Okay. So 10, 12, 17, 20. Okay. This is all comes in your the leaf node. Okay. This entire leaf node we have taken this 10, 12, 17, and 20. Okay. So now you got an idea how to search your expected range from your B plus tree. Okay. So now we have discussed how to search keys from your data. That is, you have the already complete B plus tree. So now we are going to discuss about that next step of deletion. Okay. So from the given example, we have already example here. So from this we are going to delete a node. Okay. So what we are going to delete 20 will be how we are going to delete it. Okay. So what are the conditions we need to follow? Means first we need to find that condition. Okay. So what are the conditions? Means first one is we are going to have that is a balance. Okay. Balanced. Then next we have to be followed that balanced tree will be how maintained. Then what is the order of? There is a minimum occupancies. So minimum nodes should be maintained. Then third one is if we have the underflow. Okay. So underflow means we need to reconstruct of your B plus tree. Okay. So we need to before we are deleting, we need to check that whether we are deleting your balanced tree. Okay. That is the first condition. So we are going to check your is a balanced tree. Then next, if you are going to deleting a node means then we have to keep your minimum nodes. Okay. So we are going to delete means we are going to keep your minimum nodes. So first thing is I am going to draw this same example here. Okay. Okay, so what is that? 5, 7, 10, 12, 17, then 20, 30. Okay, so all are that linked. Okay, so this is a tree. We have to delete your 20 from your node. Okay, so is it 20? Okay, so while we are going to deleting your 20 means we need that minimum 1 will be there. Okay, so what we have done, we're going to have keep that node should be have constant here. Okay, so how we means we're going to check here. Okay, so if you're going to deleting 20 means what will happen, 20 is deleted, so 30 will be how your thing. Okay, 30, then we have a same node, 12, 17, then 5, 7, and 10. Okay, so what is the change here we have done? We have removed this one. Okay, then we are going to change your the key node. Okay, so we are changing the key node from your leaf node. So from the leaf node we are converted as a key node. Okay, then we have maintained your balanced. Okay, so what we have done here, so we have your leaf node, that is a key node here, 12 and 20, then 5, 7, 10, then we have a leaf node as 12, 17, then 30. Okay, so what we have connected here, then after we are removing this key node 20 from your root. Okay, so we are going to change your new root as adding one from the existing of leaf node. Okay, there's a 30 will be added here, then we have keep this in your leaf node, then 12, then 5, 7, 10, then 12, 17, then remaining should be have same. Okay, so this is a way we are going to remove a key. Okay, so instead of that, suppose we are 20 will be deleted. Okay, so 20 will be have deleted here, then we need to check any underflow here. There is no underflow here. Okay, then it is a minimum node. Yes, minimum node 1 should be we have kept in your leaf, then balanced. Yes, all should be have the balance. Okay, so here the key node having a 2 nodes, then leaf node all we have that maximum 3, minimum 1 node should be we have to keep maintained. So what we have done here we have the 3 node will be your leaf node of left, then 2 node will be your the middle node, then right side we have a 1 node. Okay, so all should be have the balance or linked. Okay, clear? So this is the way we are going to deleting this node from your balance. This is a B. Okay, this is a balanced tree. Clear? So we have finished deletion operation, search operation. Beginning itself we done that insertion. Okay, so how we are utilizing your B plus tree in your insertion operation, deletion operation, and search operations. Okay, so the thing is you need to keep your B plus tree in your balanced mode, and we have to keep your root node, child node should be having the balance, and we have to follow that order. Okay, so what is the order of key will be have given means we need to follow that order. Okay, so we have here we have that minimum is a 3 node will be have your order. Okay, the order will be 4. We are going to remove 1, that is a n minus 1, m minus 1. So we have a 3 nodes here, so we need to keep 3 key nodes possible, then 3 leaf node will be have possible here. Okay, so maximum we have to have the 3, minimum 1. The same concept we are going to follow. So now you get an idea about how we are going to insertion, search, deletion operation should be done in your B plus tree. Okay, so that's all. Thank you.